Talk to Chase.
Today we're learning about graphing, and it's really blurry. Oh,
There you go.
there we go.
Wait, these are the old graphs. I can't use these.
Correct. New chart.
Are you taking notes?
We're cutting our charts
No,
right
we're
now.
not taking notes.
We need to talk about the picture again where everything is. We're going to go straight to graph.
We just go straight to graphing.
Let's just do it.
Like Nike, dude.
Yeah.
I guess I will.
Good time today.
Maybe. Why is it so bright?
It is
You're in the front of the room, Tyler.
You've made it.
Look, we're on 6 and 9.
You're cruising already.
And we probably should have started the video like after we were all done cutting. And she's
Yeah.
actually gonna do it. But now that I have to sit there, I'm just sitting here.
It's a minute and 30 seconds of cutting. Oh,
Oh no.
you're welcome, guys. We're giving you time to cut. You see me make them?
Yeah, do you want to throw all mine away too while you're at it?
Yeah.
I'm gonna ball it up.
Yeah.
Baller.
With my left.
It's close enough. No.
with my left.
No.
I hate missing math days.
Why? Look at
See, the
that.
bad thing is that like all of my important classes are real days except for this.
I love
So I can't just like,
There's no day that's like good for a doctor's appointment.
yeah. Doctor's
It is for me, dude. I don't do anything on gold days.
appointment.
Gold
Okay, we
days?
ready?
No.
We skipping A pause.
Yeah.
Lizzie.
We're skipping sin.
I'm a slow cutter. I have little baby scissors.
Especially the last day, because they'll have
They
finals.
have pink tape on them.
Brooks typing.
Well, my cousin's like, you know how you take tests. We should skip.
Yeah. Whenever you want.
To graph these, what do you think
One
we
of
need
you
to
told me. You
find?
got it.
Everything.
Center.
Your center's going to be important. Good, you need to. Good. What else do you want to know?
Identification, please.
What?
I'm supposed to say that. Yeah.
Why? We're just having conversation.
What else?
Listening.
I feel like
To
it should
graph
be
it, what was
one
the
step.
important? Your coverticities, good.
That's right. It's like, okay, let's make one step. It just
Why?
doesn't fall.
Yeah.
I don't know.
I can stretch this in.
You're just gonna play hooky.
Yeah.
Okay, to graph it, you need those 4 things. It is going to ask you for those 4 things in the chart, so we'll kind of do some double duty there. But we need to identify this information. How do I know my center?
Oh.
Good. Your H and your K, so your center here is 2, 0.
How many steps is this?
I'm going to stretch it to 3.
3.
It's a really good 0. One's going to say graph it, one's going to say finish your chart.
Got you.
But we're kind of already doing the chart is the next thing. 2, 0. How do I figure out if it's horizontal or vertical?
Big.
Good. So my denominators are the thingies she's referring to.
Look on the thing.
Which one is bigger?
36.
The 36. So that means my A value is what?
Wait, what's A?
A is your bigger denominator in this case.
Okay.
It changes next class. Today it is your bigger denominator. What does that mean my B value is? 2. Okay? my 36 is under Y, what is this? Okay, this is really all you need in order to keep going. And it kind of ties back to our warm-up of how we can figure out it from here.
I definitely already
Which one
did the
goes up and
problem.
which one goes vertical?
Huh?
Does A go up and B go vertical?
So in this, yes, in this scenario, yes, because it's vertical. So, to find my vertices, knowing my A value and my center, what do I do? If I know my A value and my center, how do I find my vertices? Yeah. We should also count.
Yeah, I remember I looked at that.
Another way.
Yeah.
I was in here. She always had that.
I know, me and Lizzie were having a conversation earlier and they heard the whole thing. I'm like, oops.
How am I going to find my co-vertices? Okay, so that's really the second step of use that all to graph it.
It's a diamond.
And again, do your best to make it not look like a diamond and to make it look like something curvy.
What happens if we make it into a diamond?
Make it look like you at least attempted to curve it. Deal?
Deal.
I don't expect it to be perfect. Mine's not perfect.
Yours looks like a canoe.
It is a beautiful canoe.
It definitely looks like an almond.
And this is why I'm not my teacher. What's your last step? Yeah, fill in your whole chart.
This is actually pretty self-explanatory.
Uh-huh.
I actually did it,
Yay!
but I didn't do a lot of class.
Erase those really quick.
Because you weren't here.
Yeah.
I didn't highlight anything.
You're good at that.
At syncing it. I have to do this a lot. It unsyncs itself all the time. Do I have a radius?
No. Probably. Oh,
Why not?
why not?
Why don't I have a
Because
radius?
it's
not a
never mind.
circle.
Never mind.
A circle has a radius because it's the same all the way around. I could absolutely draw a segment from the center to the ellipse, but it would constantly change in length. So we don't talk about a radius with these.
Yeah, I'm talking.
What is the length of my major axis?
6.
12.
12.
Because it is all the way.
Six.
Apparently it is already uncalibrated. That's a 12. What is the length of my minor axis?
4.
4. Those other words written there, the converse and, or the, sorry, transverse and conjugate, I put the words together, are what we will talk about next time. There's different terminology when it is a hyperbola, so those words will just be relevant later. Ignore them today. Hyperbolus? Where are my vertices at?
It sounds like some infection.
Where are my co-vertices at? And you do still have to find me your foci. Or foci. However you want to pronounce it.
Yeah, how do you
So what do we have to find to do that? C squared
Dang.
is a squared minus b squared. So what does c squared equal? So c is, and you do have to simplify it,
Square root of 32.
keep going.
6.
Because 8 has a perfect square.
3.
You do need a simplified radical there.
Ew.
Which axis is your foci, or your foci on?
It's gonna be on 2.
The major. So what's going to change for my foci? My x or my y?
Why?
What's a foci?
So they are what we create our ellipse on. So you have these points. And I showed them a video last time. That's okay. You have these 2 points called your foci. And they are what we create this whole ellipse on. So you have this ellipse that goes around them. How we defined an ellipse last time is any point on the ellipse. If you add these two numbers together for any point all the way around the distance to the foci, this is the same length.
What?
Yep, I know. There's a cool video I'll show it to you later. So like if I pick this one, and again, this is not a
I was like,
Not the
oh,
actual,
yeah, that
like,
doesn't
this
make
is
any
clearly
sense.
longer, this is clearly shorter. But if you add them together, it is the same as this added together. So your foci
So-
will be created on, so you still define them while you don't actually necessarily graph them for me. They just help you create the ellipse.
Is he good, guys?
Kind of.
So,
Okay, so when we write this, you're gonna take your center and you're gonna add your C value and subtract your C value from whichever one changes. Which one will change, 2 or 0? Good. So it will be 2, comma, 0, or just plus or minus 4 root 2. Done.
That was pretty easy, honestly.
Understand?
Did
Usually
that get
day 2
harder?
people think it's, we're gonna complete the square.
Where did the 2 come from?
Your center.
Okay.
So your foci move off, everything really moves off of this. So technically to get this, we are subtracting A to my center. Technically to do your co-vertices, you add your subtracting B from your center.
So would you do arts and crafts and math? And
That was
like
my watch.
my
Yeah.
art classes.
I don't know why I said that.
Like we cut every day.
Question.
Tape every day. I use highlighters.
Do we need another one or do we want to just complete the square?
Let's just
Complete the square.
complete the square. Oh, ew. Don't be alarmed, guys.
Don't be alarmed.
We'll figure it out.
We will. Liz is gonna talk about it. We, technically 2 classes ago. I didn't make you complete the square last time.
The smartboard is so bright.
Forgot about
I'm gonna lose my vision.
Tyler noticed the same
I
thing.
think
He's
my
like, I'm awfully
smartboard's
close
so
to
bright
the
it's
front.
making me
This is
lose
very
my
bright.
vision.
It is actually, like, it feels like I'm staring at a light bulb. You know how you look at the sun for a couple seconds and you look away and there's still the spot?
Yeah.
That's what's
I'm
happening.
trying to ingrain this on your brain. So good. What do you guys
Well,
do?
during that whole
Yeah.
ellipse thing, like, they said, do not stare at the sun.
You just said
Obviously, you
ellipse.
have to stare at the sun. Oh. Whoops.
These are ellipses. You witnessed an eclipse.
he said it loud.
Different things.
I mean, it travels in an ellipse, doesn't it?
Orbits are elliptical. Yes.
Yes. See?
Because
Whoa, elliptical.
So like you are currently
Is that why they call them
moving in an
elliptical riders?
elliptical pattern, you just don't know it.
Is that why they call them elliptical riders? Because they go on ellipse? That's really crazy. I never knew that.
And you told me math wasn't relevant.
it's not.
Okay, we need, from this equation that's given to you up there, do you know the center, whether it's vertical or horizontal, your co-vertices or vertices? No. What do we have to do this?
Change the form.
Yay! So,
See what I'm writing.
If you break in half, can you take the number out of only 1/2?
yes, now you know, good question. So when we rewrite this, just like before, we're gonna group our x's, we're gonna group our y's, we're gonna get rid of the 232. And what Nikki noticed is I can GCF one but not the other, correct? With your circle, you could always either GCF both or neither. Once we get to ellipses, ellipses and a hyperbola, you might be able to just GCF one and that's fine, okay? So on this one, do GCF what you can GCF. So this will be 9 times y squared plus 10y. And then still complete the square just like before. How do you complete the first square? Which means over here I need to add 16. How do you complete the second square? And what will I add to the other side? Here we go. Where do we get that from? Good. And that 25 is not only what's added, it's 25 times 9 since it's in that parentheses. When you factor this then, x minus what? 4, cool, plus 9 times what? Why what? Equals, I don't know. 9? Good. Seems like a number.
Wow, it's not.
This is where you stop adopt the 4, or in theory you divided out your GCF, because in circles it was the same thing. How do I put this into our standard form for ellipses?
You put the 9 on the other side. Yeah, never mind.
What does our standard form look like?
Oh wait, you divide the one side by 9,
Equal to 1.
and then one of them is gonna be like over 9, and then the other one's just gonna be over 1.
So your whole goal with this, because normally, or in these problems, you could have 2 different GCFs and a whole third different number on the right side. You're gonna have a variety of numbers to choose from to try to cancel. What is important is what our equation is equal to. In our parent function, what is it equal to? 1. So your focus needs to be to get this number over here to be a 1. So whatever this is, it has nothing to do with this 9. I know it's kind of confusing because there's 2 9s here. It has everything to do with the 1 over here. We need that number to be a 1 every time we have an ellipse. So we are going to divide everything by this 9. Does that make sense?
Yeah.
Oh.
Right? It has nothing to do with your GCF. It has everything to do with this. You want that to be a 1 because our standard form, our parent function, had that as a 1. What that will do for you is it will give you your A and B over here because you're going to have some fractions. And the other side will be a 1, which is your entire goal. You need this number to be a 1.
So you're always gonna divide the whole thing by the other side?
You're always going to take whatever that is. Yep.
Okay.
And there will be times you have to simplify. We'll talk about that.
Oh, man.
Question.
So do we not need the other denominator in this one?
So now it's 9 over 9 or just 1, right? So here, that is going to be important because that does give you either A or B. You don't have to write it by any means, but you have to know that that's a 1. Does that make sense so far? Okay, now it's exactly what we did a minute ago. So go through and try to find your center, and your horizontal or vertical, and those are what your co-vertices are. I'm going to make this slide big. Since there's so much writing on it. Okay.
How do you know which one's A and B?
Your bigger one on these, and so stress on ellipses, A is always bigger. I'm going to throw that out the window when we talk about hyperbola. But on ellipses, A is bigger.
What'd you get?
I don't know what to do now.
I don't know, I have the center, that's it.
So, where are you at?
We got the center.
Okay, cool. Where's your center?
4,
4,
negative 5.
Cool. Now what?
I don't know.
That's all we got.
That's all we got. So how can we figure out if it is vertical or horizontal?
You look at the A and B.
Good. So is this one vertical or horizontal? Is my A with X or is it with Y?
It's with X.
So what does that mean it is?
Horizontal.
So this one should be horizontal. What's my A value?
3.
Oh, it's my B value. Since it is horizontal, you will count your A value which way? Sideways, left and right, horizontally. Good. Bam. Bam. Means my B goes up and down. You draw your canoe. It's like battleship.
Wait.
Hold on.
Holding.
I feel like I just totally blacked out and I missed half of that.
Wait a minute.
So if it was vertical,
Oh.
You would count up and down 3.
yeah,
left and
so
right one.
whichever's bigger, that's,
Mhm.
okay.
Right, how do you know if it's vertical again?
your bigger number, your bigger denominator, tells you. So since the 9 is with x, the x is horizontal. So like your x-axis is horizontal.
Oh.
Interesting.
Yes, ma'am.
Okay, so like reverse to like completing the square.
Yes, like that.
Where did the 16 and the 25 come from?
So the 16, I have to even out. Oh, where did we get it? So you do 8 divided by 2, square it.
8 divided by 2.
So 8 divided by 2 is 4, squared is 16.
Okay.
Same thing with the 25. So 10 divided by 2, squared is 25. Questions there?
We don't have a radius.
Correct. So when you're filling in the chart, your center we already had at 4, -5. Cross out radius. How long is my major axis? How long is my minor axis? 2. My vertices are at what? 1, -5. 7, -5. Perfect. Where are my co-vertices at?
4, -4, 4, -6.
4, -4, 4, -6. And we have to still find our vertices, our foci. What's your C value? Good. How did you get that?
9 minus 1.
Good. Your C squared, remember, is 9 minus 1. It's A squared minus B squared. So C is 8. Square root of 8 is 2 root 2. What will change X or Y? Good.
How'd you
Your
figure
foci
that
go
out?
left to what?
How'd you figure that out?
Because my foci need to be like, what, there and there?
Okay.
Those have different X values, but the same Y value.
Oh.
Does that make sense?
Yeah.
So it will be 4 plus or minus 2 root 2, comma, -5. It'll always match whatever changed for your vertices.
Hmm.
Wouldn't it be negative? Wait.
Do plus or minus.
Yeah, I'm pretty sure it's -5. Isn't it?
Your 5 is negative, your 4 is positive. You pull it from your center.
Oh, okay.
So you go left and right of your center.
Did you get it?
Yes.
Okay.
And technically, remember, we did the same thing for this, but it's easier to count whole numbers. With this, because you're approximating anyways, just do it to this. Other questions?
Okay.
If the foci was like the y, would we put -5?
Plus or minus, whatever.
Mhm.
Yep. So this was vertical instead? Yes. Other questions? One more?
Yeah.
Yeah. Sorry, Tyler, you got that out quick.
Should I go to the bathroom? Are we doing one more?
Can you get homework?
You wanna take a nap?
Homework. I appreciate your input, Tyler. I'm gonna pass on that option.
Oh, we're trying it by ourselves?
I will help you in a minute.
Okay.
I know. Give it a go, Tyler.
Okay, you wanna watch this? Okay,
Alright,
never mind.
We got this.
We're gonna do great. Okay. So you gotta group them together. We're gonna walk them through it. Yeah. Okay. So you have to group your X's and Y's together.
Gee, pencil, marker.
And then
High five. You get a variety of
And
things.
then define the C.
Motivation.
-8 over 2.
you have to take out the 4 first.
Dang it. Guys, listen to Peyton.
I'm really happy that the people not
So
here
you
can
have
hear you talk
4.
through your problem.
4
It'll probably
X
help us, so
squared
it's perfect.
minus 2X.
Yeah.
So then it's 1.
2 2 over 1 plus 1 squared.
One, and then your y would be 1 again. And you have to make sure you add your ones over. So plus 2 on that side. So then you have
13.
4x minus plus 1 plus 2y minus 5 plus 1 squared equals 13.
Whoa, whoa. Oh, never mind.
Then you have to divide the 13 over. So I don't know how to do
Dude, I
that.
literally can't see this so bad.
Okay, so then
I'm looking at my peripheral vision right now.
divide everything by 13.
I can't see with my main vision. That's so weird.
Bro, I did
4
it
divided
right.
by 13.
Divide by 13
I got
is 0.30,
So?
0.31.
We're just gonna keep 13
Oh,
there,
you have to make that a full sign.
I guess.
I realized where we had to stop because we don't know. But we can. No, the 13's not right.
Why?
Because you have to times the 1 by the 4.
Oh,
Sorry, guys. We really
we
messed
went
up.
way too far. It's okay.
They're probably just gonna mute.
They probably are. So it's plus, so plus 1
Five.
still, and then plus 4, so plus 5. So,
I'm really looking forward to
16.
watching this video.
Yeah.
so then the 4 works out. Oh my gosh. So then we should just divide it by 4, so then it'd be 12, or would it be 4?
4 divided by 16 is what?
You
4.
know, do 4 times 4.
I don't know
So
where I
then
got
it's
12 from.
X plus
4 times
1
1.
squared over 4 plus 4 plus 1 squared
that
over
make sense?
16 equals 1. Right?
When you divide by the 16, do not give me a decimal if you have to simplify something. Do we agree this doesn't just directly cancel out? Okay. What does that give you when you simplify that?
It's over 4.
What is it over?
4.
Good. Leave it as a fraction, so just simplify what you can simplify. Don't worry if they don't just cross out. That should be your equation. Let me know if you have questions on that equation.
And then now we can graph it.
Okay, so the top line to
Mhm.
the second line, did you like simplify or?
I factored this and got that.
Factor,
And then
okay.
I factored this and got that. Does that make sense?
Yeah, you just did it in your head.
Yes. Don't you write it out. You're fine. I've been doing this for far too long.
Oh,
So it's vertical, right?
Yeah. Yeah.
I don't know she was talking to me and she said yes.
yeah. That's a minus.
Man.
Added. Don't need to write it. 'Cause now you're
Why is it a minus?
What's the center?
That's what it
Oh, well, that's what she said.
Oh, okay. So it'd be 1.
Well, because look, the
You're
negative
gonna
2
try
over
it
1 is
with
going to
this
be 1.
Oh, got it.
Wait, so this, the 4 underneath and the 16 underneath, that's our a squared or b squared?
Which one's A?
16 is bigger.
Good. 4 is 2.
And so now we can graph.
Is this vertical or horizontal?
I was gonna ask that. You tell me, Liz. And you weren't asking me. You were asking
Wait.
yourself.
Oh, yeah, it's vertical.
Good. My y has the bigger, so this is vertical. Down 4. Left 2. Right 2.
So then,
So fun. Looks so good. I will never not see them as canoes now. Getting stops in.
They're just a very obtuse banana.
also an option. Yeah. So
Yeah.
it's a banana I would pass on.
What does obtuse mean?
Like big, large, open, wide ankle.
So in geometry, what does obtuse mean?
It means, well, it doesn't really mean anything, it just means a triangle. It's the name of a triangle.
The girls are right, I would listen to them. In geometry, it's that it is a wider than 90-degree angle.
But like, when do you use that when you're not talking about a triangle?
I mean,
I use
people
it in my
refer to
English paper. I was talking about a fat guy and I called him obtuse.
Wow.
do that.
Better than saying fat.
Cause it was like a
Is
journal
it?
thing.
I
was
think
a
so.
beggar,
I
and
mean, if I was fat, I wouldn't want to be called
obtuse.
obtuse.
Okay, do we agree with what I filled
You're
out there?
obtuse.
Yeah.
Make me
Focus,
feel
we'll
bad.
finish. What is my major axis length?
6,
Whoa.
8,
What is my minor axis length?
4,
Good. What is my C value? 2 root 3. Good. It was square root of 12, absolutely. And then you simplify that and you get 2 root 3. I take my center and I add or subtract my C. Will I add or subtract it to X or Y?
Why?
I still don't
Is
get
that a WH Y? Or
Yeah.
are you telling me? Because it is vertical. So I need again my focus to be like above and below. Right?
Okay.
Yeah.
Your foci are always on your major axis, which means I need them to move vertically but not horizontally. So my negative one stays the or wait, my positive one stays the same. That was right. I have too many
X
negatives.
stays and then your Y.
I mean, you have too many ones.
Too many one, like, is that one supposed to be that? Yes. X stays the same, my Y will plus or minus 2 root 3.
Cool.
So we will just say goodbye to our friends.
You wanna say bye?
Bye, guys.